Hi folks, I'm Mr. V, and today's illustrative mathematics from Unit 2, Congruence, is about proofs with quadrilaterals. And by the end of this period, at the end of this lesson, what the goal is, the objective is for you to be able to say, I can critique a proof about quadrilaterals, I can prove theorems about quadrilaterals, and I can rewrite a conjecture to be specific enough to make a proof. And first thing we have is the definition of a parallelogram. Parallelogram, by definition, is a quadrilateral with two parallel opposite sides. It doesn't say anything about the lengths. It doesn't say anything about the angle measures. It just says that the opposite sides are parallel. A rectangle also says it's a quadrilateral with four right angles. It doesn't say that the opposite sides are congruent. It doesn't say that the opposite sides are the same, different sides of opposite sides. It doesn't say anything about the sides. It says the angles all equal are 4 or 90 degrees. That's all that the definition of a rectangle is. And you will use those, so make sure that these are in your reference table. You'll use these when we do proofs. Now here's a couple of statements. Do you agree with either one of these? All rectangles are parallelograms. All parallelograms are rectangles. I don't think all parallelograms are rectangles because I could have something like this, like a rhombus or something like that. It's actually true that all rectangles are parallelograms. If you remember the graphic organizer I've given you in the past, you have the family of parallelograms, rhombuses and rectangles are underneath it, and one of their children is the square. So the square has all the attributes of its parents, the rhombus and the rectangle. Rhombus and rectangle are both parallelograms. They both have all the attributes of a parallelogram, but they're special because they have something else. So which statement do you agree with? That all rectangles are squares? I don't think so. All squares are rectangles. Well, yes, this has to be true because a rectangle, by definition, is a quadrilateral with four right angles, and squares all have four right angles. So here is an applet. Well, first of all, this is a rhombus. Definition of a rhombus is a quadrilateral with four congruent sides. Now, in this applet, we go to it, and it gives you some quadrilaterals to explore. If you do a drag test on each one of the corners, you can see that some of these can be made into a rectangle. Some of them are always a rectangle. This is always a rectangle, which means it's also always a parallelogram. This one I think is a square, and you get to try to figure out which ones are which ones are which. And some of them might confuse you. So, like for instance, this looks like it might be a parallelogram, but when you actually do a drag test on W, you find it's a trapezoid. So explore these. This is what we do. We make a assertion, and then we explore it and make a conjecture. What conjecture can you make out of a rhombus? Well, that all four sides are congruent, and then we can actually go about proving it. And in today's lesson, we're going to go from conjecture to proof. First of all, here's the conjecture. All rectangles are parallelograms. We've explored the applet enough to know that we believe that this is true. We've made the assertion. Now we've explored it to make a conjecture. Now we're going to try to make a proof out of it. First of all, what do you know about rectangles? Well, we know that it's a rectangle it's a quadrilateral with four right angles. What do we want to prove? We're trying to prove that the opposite sides are parallel, because that's what a definition of parallelogram is. Can we rewrite the conjecture stating what is given and what it is we want to prove? So if you were to rewrite this, you would say, given rectangle ABCD, where angles A, B, C, and D are all right angles, prove that segment AB is parallel to segment DC and segment AD is parallel to segment BC. That's what we'd be trying to prove. We're trying to prove that it's a parallelogram, which means that both pair of opposite sides are parallel. And what information is given? If I were to mark only the given information, I'll put this in blue, I'll put the four right angles like this. That's all that you're given. Now, what it is you're trying to prove is that these two sides are parallel and these two sides are parallel. How can we do that? And remember, if I write it like all rectangles are parallelograms, that's not a very good way to do it. If I say, if I have rectangle ABCD, I want to prove that it's parallelogram ABCD. That's not enough information to be specific. So I'm being very specific, saying that these four angles are right angles, and I want to prove that these opposite sides are parallel. And one way to do that, I'm going to mark it on here. I'm not going to write it out because of interest of time. I will just mark it on here. I'm going to say, we know that if we have parallel lines and a transversal crosses parallel lines, that same side interior angles are supplementary. That is, they add to 180 degrees. So here we have these two angles. We also know the converse of the same side interior angles. We have proved both of these angles, which says if same side interior angles sum to 180 degrees, then the lines are parallel. So the same side interior angle theorem says a transversal crosses parallel lines to form same side interior angles that are supplementary. Converse says if the same side interior angles formed by transversal crossing lines are supplementary, then the lines are parallel. So I'm going to say that since angle A and angle D are supplementary, this transversal is crossing these lines must be parallel. Since A and B are supplementary, since they add to 180, 90 plus 90, that means that this is a transversal crossing these two lines. These lines must be parallel. It's a very short, very simple proof, but it's not trivial. It's something that needs to be thought out as far as proofs go. And so I'm giving plenty of time for you to do that. Now, here are a number of conjectures, and you should choose one and try to prove it. And try to rewrite it as a given and prove statement, and try to prove it. And you can use GeoGebra, this applet, to try to do that with. You can also use this one to try to do your proof. Different ways of doing the proof. And you're going to write a statement. You'll mark everything that's given on the drawing. The second thing you do is mark what's implied. And for you to mark what's implied, you have to have a reason or a rule to back it up. So, like, for instance, vertical angles are congruent or something else. Now, let me show you a couple of examples. These are things that we would go through in class. I'll come back to this one. If a parallelogram has at least one right angle, then it's a rectangle. You're given that it's a parallelogram. So I've marked that on here. It's a parallelogram. That means that both pair of opposite sides are parallel. This would be given. Given one of the angles is a right angle. So I'm going to say that this is a right angle. Now, what do we know about parallelograms? So this is what's given. We know that in a parallelogram, lines crossing a parallel, same side interior angles are supplementary. This is the same side interior angles theorem. Interior angles theorem. Transversal crosses parallel lines from congruent. Same side interior and same side exterior angles are supplementary. So if this is angle 1 and this is angle 2, we know that they have to add to 180. So angle 1 plus angle 2 is equal to 180. So angle 2 must be 90. Since they are same side interior angles, you can say that this has to equal to 90 as well, because they have to add to 180. We could also do that with this angle, angle 3. So angle 1 plus angle 3 is equal to 180. And that means that since angle 1 is 90, angle 3 has to equal to 90. So far, I've proven 3 of the 4 angles are 90 degrees. To prove it as a rectangle, what I'm actually trying to prove is that all 4 angles are right angles. Now, one other thing that we know about parallelograms is that the opposite angles are congruent. So this would have to be 90 as well. Therefore, this is a rectangle. Here's a different proof. The diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here's my diagonal. I'm going to say that given ABCD is a quadrilateral, and these two intersect at M, I'm given AM is equal to CM. I'm given that BM is equal to DM because the diagonals bisect each other. We're going to try to prove, well, given AM is equal to CM, and BM is equal to DM. Prove AB is parallel to DC. This is prove that it's a parallelogram if both pair of opposite sides were parallel. This is not enough. One is not enough. I need to also prove that AD is parallel to BC. And I'm going to just talk you through that. Here I have a side that's congruent to a side. I've got vertical angles. So angle 1 is congruent to angle 2 because they're vertical pair. That's the reason it's a vertical pair. And I have a side that's congruent to a side. So these two triangles on the top and the bottom are congruent by the side angle side triangle congruence theorem. Since they are congruent, all their remaining corresponding parts must be congruent. So this angle, which we'll call angle 3, has to be congruent to angle 4. Also, this angle, which we'll call angle 5, has to be congruent to this angle, which we'll call angle 6. Now, we know that a transversal crosses parallel lines to form congruent alternate interior angles. That's the alternate interior angles theorem. The converse of that, which we have also proved of the alternate interior angles theorem, says that if alternate interior angles are congruent, then the lines are parallel. Since angles 3 and 4 are congruent, these two angles, that means that these two lines must be parallel. That is, BC has to be parallel to AD. Since, if I draw this again, I'm going to draw these ones. These two angles are congruent. This is, that's not, I'm going to do it this way. Since these two angles are congruent, angles 3 and angles 4, no. What am I doing? Hang on just a minute. Here we go. This is my transversal. Oh my goodness, what am I doing? I have to prove, okay, so I've proved those two lines are parallel. I guess I have to show that these two angles are congruent as well by vertical angles. So these two triangles are congruent, so I can show that this angle is congruent to this one. Because when I do that, then if I draw my parallel lines, draw this, then the alternate interior angles are congruent. Therefore, this has to be, these two sides have to be parallel as well. Ugh, sorry. If we're given, we want to prove that this is a kite when we know that AC is perpendicular to DB, that's marked, and AP is congruent to CP. This is all that's given. What I would mark on here is this angle is also 90. This is congruent to itself. By side angle side, the two triangles are congruent, which means this has to be congruent to this one, CP, CTC. Here we have this side is congruent to itself, so we have side angle side. These two triangles are congruent. Because they're congruent by the corresponding parts of congruent triangles are congruent, CP, CTC, this side has to be congruent to this one. And that's my proof. Elena wants to prove that a figure with 4 right angles must have congruent opposite sides. Show how she can use the fact that rectangles are parallelograms in her proof. So I'm just going to walk you through this. If we are given quadrilateral with 4 right angles, here we have it, 4 right angles. And what we know is that this is a rectangle. And we've proved that all rectangles are parallelograms. So this is a parallelogram. Since it is a parallelogram, we know, because we've proved that in a parallelogram, both pair of opposite sides are parallel, are congruent. So there is my proof. 1, it is a rectangle. 2, rectangles are parallelograms. 3, parallelograms have opposite sides that are congruent. Something that we've proved before. And I think that that's the end of the lesson. I'm not sure. Let's just check this out. Most of this lesson is going about trying to prove something and trying to check it with your partner. The activity synthesis The lessons, let's see, activity synthesis. Make sure that you get this into your reference chart. If you have a parallelogram with one right angle, it is a rectangle. And the lesson synthesis. Andre says ABCD is a rhombus, then it's a parallelogram. That's the statement we'd be trying to prove. But what's wrong with that, with the critique of this, is he doesn't give enough specific information to make a proof. So it needs to be more specific. Bob does a better job, but still not perfect. He says if AB is equal to BC is equal to CD is equal to DA, then AB is parallel to CD. What's wrong with this? Well, what's wrong with this is that it still doesn't give us enough to prove that the opposite sides are parallel. Both pair of opposite sides have to be parallel to be a parallelogram. Claire says if ABCD has 4 congruent sides, then the opposite sides are congruent, so it must be a parallelogram. And this is off because we know the parallelograms have opposite sides that are congruent, but we don't know if all shapes with opposite sides that are congruent have to be parallel, so we don't know the converse of that to be true. Proving this wouldn't prove that the shape was definitely a parallelogram, because if we knew the converse of it was true, then it would be, but we don't know the converse of it is true. So lots going on here, folks. Good luck and success.